So here we have another triangle. We're given an angle, we're given a side next to our angle, and we're given its opposite side. So if you draw that out, you have your angle, a side next to it, and you have your opposite side. So this is a side-side angle situation. So now we got to decide how many triangles we have using this little cheat sheet right here. Now, if it was not a side-side angle situation, I don't have to be concerned about any of this, and I just go ahead and work it out. But being a side-side angle situation, I need to check this out. Now, I always like to see, is my opposite side greater than my adjacent side? Opposite's 5, adjacent's 10. Definitely not. So it's not that one. So now I go ahead and I take a look at these next two. It's always, for both of them, it's opposite side, and then over here it's adjacent, and then sine of the angle. So I put down opposite, adjacent, and sine of my angle. My opposite of my angle is 5, adjacent, the side next to my angle is 10, and then I go to the sine of my angle. Now, I'll type this into my calculator, and I get 4.23. So, opposite side's 5, this is here. I know it's not this one here that says equals. Then I want to check, is my opposite side less than this? Well, 5 is not less than. So it's not the top one, not this one here. So it's the otherwise, which is 2 triangles. So I'll need to consider that situation of 2 triangles. So one of my triangles is going to look like this. Just basically what I had up here, but actually connected to form a triangle. So I'm going to start off by solving this. Now I have an opposite pair, and that's my A's. So now I can go ahead and find angle B because I have side B. So I'll start off with that. My sine of my angle over my side equals the sine of my unknown angle over my side. That's opposite of that one. Now I need to try to get B by itself. So I got to get rid of the dividing by 10, so multiply everything by 10. Now I have to get rid of the sine. So to undo sine, I need to take the sine inverse of both sides. So this is my calculator ready form. I'm going to type that into my calculator, and then I get my answer of 57.7. Now, side for your other triangle, really all we're doing is we're taking this leg and we're swinging it back over here, and that forms our other triangle. So we have that one over here. So we have our opposite, our angle, and our adjacent. Now, the first thing we found over here was angle B. That helps us when we're looking over here. Angle B in our second triangle is supplementary to the angle in our first triangle. Well, so remember, supplementary means to add up to 180, so we'll go 180 minus that angle of 57.7, and we subtract and we get our new angle B. And here, looking at our diagram, it looks like it's an obtuse angle, larger than 90, and it makes sense as we look at this. So to find your second triangle, the first angle that you find in your first triangle is supplementary to that angle in the second triangle. Then you work out everything else from there. So if this angle back over here is 57.75 and this angle is 25, well, all 3 angles have to add up to 180, so I can find angle C by subtracting my 25 and 57.75 from 180, and I get angle C to be 97.3. If I know this angle, I can then use law of sines with my original given information here in A to be able to find side C. So I take the sine of my angle. I'm going to put it in the bottom because I like to have what it is I'm looking for on top because it just saves me one step. The side opposite that goes on the other part of my fraction, so that's 5. I'm looking for angles or side C, so then I got to go over the sine of angle C. So I need to get C by itself. I got to get rid of dividing by sine of 97.3, so I multiply by that. And it's my calculator ready form. I type it in. So those are my answers for my first triangle. Then I have to solve my second triangle. Once again, I already figured out angle B because that was supplementary to my first angle B, but nothing else is related between these triangles. So now, if I know this is 25, this is 122.3, I can subtract from 180 to get angle C, and I get angle C to be 32.7. So now I can use law of sine. So I take my original given information equals to side C over the angle C of my second triangle. Multiply both sides by the sine of 32.7 to get C by itself. And that's my calculator ready form. Type it in and I get my answer. Looking at this one here, we want to draw this out. We have our angle, an adjacent side, our opposite side. Once again, it's an SSA situation, so we need to figure out how many triangles. So I'm going to take a look. I always like doing the first one because I can pretty much do that in my head. Is the opposite greater than the adjacent? The opposite is 15, the adjacent's the 10. Yep, it's that, so that means it's one triangle. So then it's pretty easy and straightforward. So I just have my one triangle, I'll draw it out. So now I would need to find angle B. Well, I have an opposite pair, so I can use law of sine. So I'll go the sine of my angle over the side opposite of that equals the sine of my unknown angle over the side opposite of that, which is 10. Now I need to get B by itself, so I'm going to multiply both sides by 10, and that's equal to the sine of my angle. Now to get B totally by itself, I'd have to undo sine, so I have to take the sine inverse of both sides. This is my calculator ready form. So now I'm going to type this into my calculator. I get my approximation. Now once I know that angle, and I know this angle, all the angles add up to 180, I can go ahead and get angle C. So subtracting them from 180, I get angle C to be 125.7 degrees. Well, if I know that, and I have my opposite pair from the A's, I can get side C. So I'll go the sine of the angle I was given, put that on the bottom, over side A equals side C over the sine of angle C. Get C by itself by multiplying by the sine of 125.7. Calculator ready form, and type it in. Same idea here. We have an angle, an opposite side, and an adjacent side. I need to figure out how many triangles it might be, because it could be 0, could be 1, could be 2. So my opposite side's 5, my adjacent is 9. So it's obviously not the top one. The second two are opposite and adjacent side of the angle, so I'll take the opposite of 5, my adjacent side of 9, sine of my angle of 50 degrees. I'll work this out here on the left, or I mean on the right. And in this case, I get 5 is less than what I have over here. And that's the third situation. If the opposite is less than, it says it's no triangle. Well, if it's not a triangle, we can't solve it, so we're done.